This video we will talk about a couple of techniques to use with the factorization of polynomial. So suppose we are given this polynomial 27x cubed plus 45x squared minus 12x minus 8. Okay, and the first technique is the technique of use of a calculator. When you go to, depending on the calculator you're using, you're probably looking at the apps of a calculator or of an equation feature of the calculator. So use that to try to find all the roots of this polynomial given. And firstly, I will talk about the idea of roots. The right term to be used in this case is actually 0, but we haven't reached that particular stage yet. But bear in mind that really 0 is a more suitable term than the term of root. But at this juncture, you just think of root as 0 as root. Okay. So anyhow, if you use the calculator, you're able to find the root. You found something in the decimal or some other thing in decimal. For this particular example, you discover that one of the root is actually negative 1/3, and so you can use this to form one of the factors. By doing so, you have x equal to negative 1/3. What you want to do is rearrange this so that the left hand side would be like this and the right hand side is 0. Okay, using this you form this, and in other words, one of the factors of the polynomial that in the discussion is therefore 3x minus 1. Okay, I think it's 3x plus 1. I made a mistake here. It's plus 1. And the next step is that you could then use a long division and divide the whole of the polynomial, and you should actually get a quotient like this. Now what you do then is form this factor, like this product, with the divisor, the one you discovered here, and also the quotient, and that's how you actually factorize this. And then you could use a quadratic formula for the quadratic factor, and in the end you should be getting this. The factorization will give you 3x plus 1. The other two should be x. Oh wait, I think it should be 3x, not x. So it should be 3x minus 2 plus 2 third 3, and also let me extend it should be at the end here, right here, but not enough space. It should be 3x minus, in brackets again, minus 2, but this time we subtract 2 square root of 3. So this would be how you factorize if you use the calculator. And next we'll look at a technique, a very algebraic technique. Let's go there now. So the second technique, of course, is a theorem. It's called a rational zero theorem. And again, to remind you that the idea of zero is something like a root of a polynomial equation. Anyway, now here is it now. The polynomial that the same point we used just now. The task first is to identify the factors of the leading coefficients. Now, what is it, the leading coefficient? Here is it. This is your leading coefficient, and let's give it a name. Let's call it Q. So, okay, so the leading coefficient is 27. Let's call it Q equals 27, and the task is for us to identify its factor of Q. Factors are 1, 3, 3, 3. Of course, there are only two distinct factors, 1 and 3. So when we work with them later, we just use 1, 3 instead of all 3 of the 3. So 1, 3, 3, 3 instead. And the next task is to identify the constant. And here, of course, the constant, as you can see, is 8. We can ignore the minus in front of the 8, just work with 8. So so the constant is a, and I give it a name called a p. So any constant will be called p for a polynomial. So any leading coefficients will be called q, and then so on will be useful later. You see why. And the factors in our case 8 is 1, 2, and 4. Okay, now what this rational zero theorem says basically is that if this polynomial contains well, it has at least one rational zero. So all the possible rational zero of this cubic in this case, and in case you've forgotten what is a rational means that the zero is well, it's a fraction. Okay, it's a fraction. And so what it says is this, that it has a certain form, or if it's a rational zero, if at least one of if it has at least one, then it must have this form. If it could be that all three of these are zero, in this case, or four will be rational zeros. It has a certain form, is in the form of p negative positive of p divided by q. It means in our case, what we do is first we start with the first factor of p, and then work with all the other factors of q. Lucky for us, because there's only two in this 1, 3, and for this one we start with 1, and that means in case the possible rational zero for this particular cubic polynomial is, as well, again, 1 divided by 1, positive, negative. See, the 1 came from here, and then divided by this 1, and then the next will be 1, of course, positive, negative, divided by 3. The 3 is now the value that comes from here, is q value. And also, and now we are done with this one. So we now work with the second factor, that's the 2, and so that means the possible factors now is like positive, negative 2 divided by 1, and positive, negative 2 divided by 3. P over Q, remember. And lastly, we'll work with the last factor of P, that's 4. It means we'll have positive, negative, possible, of course, 4, 1, and positive, negative 4 over 3. But if you notice carefully, you find that some of these possibilities are really integers, and of course we focus on the rational zeros. So this 1 can be eliminated. 2 over 1 is really positive, negative 2, and 4 and 1 just positive, negative 4. So in other words, we'll have 6 possibilities: the positive, negative 1/3, and positive, negative 2/3, and positive, negative 4 over 3. And what we do then is that we can now use the trial and error approach to test whether any one of these 6 values, or at least 2 or 3 or 4, we're not sure, would make this whole expression equivalent to 0 later when we substitute it with the as a value of x. And once we decided 1 or 2 of them is a 0, then we can use the method you used earlier to form a factor, and then finally we can use a long division and repeat the process again. So here, these are the 2 methods, by calculator and also algebraic theorem, the rational zero theorem, and hope that they are useful in your task of factorizing polynomial.